In this video, we're going to talk about operations with fractions, and we're going to move into multiplication. Now, interestingly enough, out of all of the operations with fractions, multiplication has more visuals, and they're pretty good. So we're going to go through the different types of visuals we'll see, and then talk about how to multiply fractions. In fact, multiplying by fractions is easier than adding them or subtracting them. Okay, so here we go. Let's look at this example of 4 times 1/3. So one way we can visualize 4 times 1/3 is the idea that we use repeated addition. In other words, if we were to take 1/3, right, if each of these blocks represents 1/3, and we have 4 of them. Now I'm going to put a space between those. 1/3, 1/3, 1/3. Okay, because these 3 1/3s would form one whole plus the other 1/3, which is kind of badly labeled, but it's fine. There we go. So that gives us a total of 1 and 1/3. Or another way of saying that is there are 4 thirds, counting 4 of them, if you put it in improper fraction form, which we really probably wouldn't. We would strive to do mixed numbers. Okay. Another visualization of this is to take the number 4 and then take a third. So here, I'll draw the number 4 with rectangles. We'll do 4 rectangles here, like that. Okay. And then if we take a third of those rectangles, and really what we're saying is, well, here, sorry, let me label each of these 1, 1, 1, 1. Okay. And then dividing them up into thirds, and then taking a third of each rectangle results in 4 thirds or 1 and 1/3. So those are two visualizations of the same concept, the idea that we could do a repeated addition or actually take a third of 4. Okay, the other type of picture or visual that we use is when we're multiplying two fractions, like 1/3 times 1/4. In this case, they use a rectangle to represent each fraction. So I'm going to start with representing 1/3. So here, let's represent 1/3. Oh, I already tell I did a bad job on the spacing. Okay, there we go. 1/3. So this is representing the 1/3. And then to represent the 1/4, we do the other side. Wow. Get less in the middle. There we go. Better. And there's our 1/4. All right. And then the two of those combined, the 1/3 times 1/4, taking a third and a fourth, ends up being a single rectangle. Okay. Because what we're basically doing here, let me kind of highlight this, is we're selecting 1/3 of the rectangle, and then we're selecting 1/4 of the rectangle. Sorry, should have gotten rid of that. So the double shaded region right here, where the two highlights overlap, represents 1/12 of the entire rectangle. Actually, I don't know why I didn't do it in green and write it up here, since it divided the rectangle up into 12 pieces. So that's kind of the visualization for doing a 1/3 or two fractions times each other. Okay, now from the book, and we'll just apply this without visuals now. If you have A times B, I'm sorry, A over B times C over D, what you end up doing is multiplying the two numerators and multiplying the two denominators. And you could simplify if necessary, but that's the basic strategy for multiplying fractions. No common denominators needed. So in this case, if I'm multiplying 1 times 8 is 8. 2 times 9 is 18. I can reduce this top and bottom by at least 2. And that'll end up giving me 4/9. And that's how we multiply fractions. So the only way it gets exciting is if we have a fraction like 2/5 times a negative 24. The book actually has a rule for this. Oops, sorry. I'll write it over here. And the rule they say is that if you multiply a constant times a fraction, that constant ends up multiplying by the numerator. But a lot of people often remember the trick that you can take any whole number or integer and put it over 1, and then use the rule that we just did above. Either way, both rules do in fact work. And the nice thing about this rule, this one over here that I just introduced, is that it uses the idea of the repeated addition to explain it, right? If you're taking AB and adding it k times, basically all you end up doing is adding the numerators, and that's just k times a. But yeah, both of them work. They both give back the same rule, and they're both not too terribly complicated. So here, let's go ahead and do that. 2 times 24 is 48, and it's negative. 5 times 1 is 5. And then I'm going to go ahead and change this into a mixed number. So 5 into 48. Let's see, 5 goes into that 9 times. And with a remainder of 3. So this will be negative 9 and 3/5. All right. And then actually, since we just kind of saw a mixed number, let's do an example with some mixed numbers. Like let's do 3/4 times 6 and 1/5. All right. So what we want to do when we're working with mixed numbers, and this is something that you can really do every time you work with a mixed number, is change it to an improper fraction. So I'm going to use the process where I multiply 6 times 5 plus 1. That gives me 30. And that's going to be the numerator on the mixed number. And now I can use the multiplying straight across. So that's going to mean 90 over 20. Oops. Sorry, that's supposed to be a 1. That's a 31. Wow, took me a second there. Just caught that, sorry. 31, which is now 93. Different. Okay. All right, and now I want to reduce this if I can. So let's see. 3 definitely goes into the numerator, but not into the denominator. 2 goes in the denominator, not in the numerator. 5, yeah, okay. It doesn't reduce. So what I'll then do instead is change it to a mixed number. Okay, so 20 is going to go into 93 4 times. It's going to give me 80 and a remainder of 13. So my final answer is 4 and 13/20. Okay, so let me do one more problem like that. And maybe you could pause the video after I do this. Try it yourself. 3 1/8 times negative 2 1/3. Okay, give that a shot. I'm going to go ahead and work on it right now. So I'm going to change each of the mixed numbers into improper fractions. So the first one, 3 times 8 plus 1, that's going to give me 25 over 8. The second one, 2 times 3 plus 1, that's going to give me 7 over 3. And then I bring that negative basically down. And in fact, since we have the rule with negatives, I'm going to go ahead and just put it up on the 7 for right now, just to make it easier. And let's do 25 times 7. Here, I'm going to grab my calculator. Actually, wait, I could do that in my head. That's quarters. 7 quarters is 175. And then 8 times 3 is 24. Okay, so now Let's see. Yeah, that doesn't reduce. So I'm going to go ahead and change it to a mixed number. You might want to use your calculator for this if you got stuck. Let's see. I'm going to take a guess. 24. We'll do 24 times 5. Let's see. That's 120. That's not big enough. Let's try 7. 168. There we go. That'll work. 168. Okay. So that's going to give me 7. And that means that this is going to equal negative 7 and 7/24. And there's all you have for fraction multiplication. All right, division with fractions. Thankfully, division, because it builds on multiplication, is actually pretty straightforward as well. And we won't spend a ton of time on the visuals for division. Really, we're just going to use the idea of repeated subtraction. Okay, so let's try one. Let's do 3/5 divided by 1/10. So what we're saying is, how many 1/10 can we subtract from 3/5? Can we subtract from 3/5? That's a weird 1/10. There we go. Okay. So let's draw it out. Let's go ahead and start with 3/5. Okay, so for 3/5, there we go. And we're going to shade 3 of them. Now the book just compares it to a 1/10 and figures out how many 1/10 they can fit in. I think it's actually easier just to divide this up into tenths. Each one is representing 1/10. Now, each little rectangle is representing 1/10. And based on the shaded region, since each of these are 1/10, I end up with 6 of them. Oops. One more. So I have 6 that actually fit into 3/5. So 6 1/10 fit into 3/5. Okay. So the division process, they kind of devote a little bit of time to the fact that visually speaking, it makes sense to kind of have a common denominator to do this, which is basically what we did. We took the second fraction and kind of got the first fraction to have the same division so that we could do a repeated subtraction, okay? Because with subtraction, we do need a common denominator. So they approach division 2 ways. One way using LCDs, which they refer to as the old way. So we'll do both ways to just demonstrate it. Old way. And this is using the lowest common denominator. So what you would do is you would pause for a second and find the lowest common denominator for these 2 fractions. In this case, it would be 20 since the 2 numbers have nothing in common. So I'd multiply the first fraction by 4, which gives me 8/20. The second fraction by 5, which gives me 15/20. And then I'm going to go ahead and return to the division, 8/20 divided by 15/20. And because they have a common denominator, they're broken into the same number of pieces. It basically allows us to drop the denominators and say that this is really just 8 divided by 15, which we can represent as the fraction 8/15. And that's it. That's how we could approach that. That's the old way. That's really just using the visuals for repeated subtraction. Okay. Okay. The new way, and the way you were probably taught in school, is to take the second fraction, use its reciprocal, and change it to multiplication. which basically then means we multiply the numerator and denominator. All right, so approaching it that way instead. 2/5 divided by 3/4 is going to be 2/5 times 4/3, multiplying straight across, 8/15. Oh, so easy. So there you go. New way is the superior way in terms of time. And math people love saving time. All right, let's try a division. And we'll do it, we'll kind of jump to the most exciting of the division problems. We'll have some mixed numbers. So just like with multiplication, I'm going to go ahead and turn these into improper fractions. If you want to pause the video and give it a try, go for it. I'll go ahead and proceed. I'm not going to show the work now for how to get the improper fraction. I'm going to go ahead and just do it in my head. I'll say it out loud and do it in my head. So I'm going to do 5 times 3 plus 1, which is 15 plus 1, which is 16. Divided by 1 times 8, which is 8, plus 1 is 9. And now I'm going to flip the second one and multiply. So 16 times 8 is 128 over 27. I did that on my calculator, by the way. And then I'm going to go ahead and change this into a mixed number. I just realized I've been working with the red pen instead of the green. That's fine. Get all stressed out about that. Okay, so let's see. 27 into 128. Is it going to let me write? There we go. All right. I'll take a guess. Let's try it times 3. 81. No, not enough. Okay, 27 times 4 maybe? 108? Yeah, that'll work. So that'll give me a remainder of 20. So this is 4 and 20 over 27. And that's how we do division and multiplication with fractions.